this up. All right. Ba 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 ba. Let me go try to set this thing up. I am live. That is true. Let me just make sure I can see chat. I can't see chat right now. Stream manager, is that the right thing to click? Okay, cool. Dun dun. Then I will go here. Then I go V2. That. Go here, drag that there. Figuring this stuff out on the fly. Cool. All right. We'll give people a few minutes to roll in. So move that over. It's not my account. Got my phone. You can all watch me. This is exciting. It's like it's a real work live stream. Me silently working on something that you can't see. Oh my gosh. Jesus. Okay. Sorry, we're doing two auth right now. All right, one second. I swear I'm gonna get back to everyone. I can't see anyone who's in the chat right now. Boom, 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 boom. All right. Hello everyone. Welcome to the, I don't know how many at this point. I think 5, 6, 7 live streams that we've done. So every single time I basically say the same thing at the beginning. This is not a presentation, although I guess at this particular moment I'm going to go over a presentation because I'm interested in sort of talking about it. The point of the live stream, though, is to give folks insight into, what does it mean to work at the Wikimedia Foundation on ML in a given day, and what is it, what are the things that we're thinking about, what are the things that we are working on. It is not us presenting what we think, like the solved problem, right? Like celebrating that we figured something out. It's us actually doing, presenting us and showing us working on the stuff that we haven't figured out yet, with the idea being that, like, we are an organization that's transparent, and so, like, in that case, you might want to see us sort of struggle with an issue or not actually understand what's happening with an issue or something like that. And so for today, the thing that I wanted to look at was this updated roadmap that I've made for the team. So this is our, like, internal roadmap of where we are and where we're going. And I'm hoping that by talking it out with all of you, I'll have a better idea of how I feel about it. I'm pretty sure I'm happy where it is. I'm pretty sure that it feels good, but there's a real possibility that sort of, talking with all of you about it, I might end up might change things, might move some dates around, might say something differently that I think is more accurate. And then if we have time, I'll also, kind of want to talk about model cards, because now we're sort of, we made our proof of concept of the model card, which I was just talking about, and I could go fling it up here. Here's the link for this. I'll paste it in chat. And then let me go grab the link for the model cards. Because we're getting to the point now with the model cards where I think we've proven out the proof of concept that like we proved out that it works. Like, you can make a model card. They are interesting. We can do it programmatically, so we can build them at scale. And now we kind of need to go back and decide from a product perspective, like, like what exactly should be in the model card, not rather than just like trying experiments with stuff out. Actually sit down and say, okay, this is a product that we want to support, we want to host. What are the stakeholders that we need? Like, do we need to have, say, design come in? Do we need to have language come in? All that kind of stuff. So we'll start with the presentation, and then we'll see. As always, you can paste. You can type any kind of questions that you want or any comments or anything into the chat window, and then I'll read them out and I'll answer them. So I don't really want to do the presentation mode, so I think I might just like make this really big for everyone. Go see. Can I do that? If I just make this bigger, is that going to work? No, it's not going to work at all. Okay. It's probably big enough. It probably doesn't matter. Okay, cool. So I think about a year ago, I made a version of this slide deck that was the first attempt at like a roadmap of what I wanted to sort of have the team focus on at the foundation, to sort of like a vision of like where the heck we're going. And what happened recently is like we've made some changes, and a really, really prominent volunteer who is like my mentor to the world of being like a really long-term Wikipedian was like, hey, do you have like an updated roadmap? I want to know what's happening. And I was like, no, I don't. I should make that. And so this is the attempt to like make that for her, and then make that for everyone, and we'll post it out there publicly so people can see. So let me just we'll just go through it. So this is the team, right? There's 5 people on the team, and we're currently hiring 1 more. I'm gonna you can find the job. It's a machine learning engineer role. You can find the job on the job website. The reason we have this mix of MLEs and SREs is because my team works on like a mix of ML and MLOps. We are the ones who are like primarily responsible for MLOps, but then we're partially responsible for like creating and training models. The model that the workflow that we seem to do a lot is that like the research team is the one who sort of takes it from absolutely nothing to like a Jupyter notebook that works, and then my team is supposed to take that on and put it into production and make it go at scale. If you're here, I'm going to skip over the machine learning 101 thing, but you can see that was my attempt. This is MLOps 101. I think the thing that sort of matters with folks is like, this is the idea of MLOps, right? Like you could have anything. You could have any product right here. I say website because obviously Wikipedia, which is the main thing that we support, is a website that creates raw data, user data. Person visits its page, person buys product. I guess no one really buys product here, but like someone could buy a product. That all gets put into your big data lake. You then process it for the feature store so your team can access it. You use that to train models. You compare that new model that you've trained to a previous version of the model to see which one's better. The best model, right? If it's today's model or whether it's yesterday's model, you select whatever one's best, you put it to production, and then you use that to serve predictions back to the website, right? And it's like a big circle, right? Over and over again. Maybe the circle could sort of be like once a year, but it could also be like every hour if you really went for it. Or live if you wanted to do online, which adds a whole bunch of complications. For us, oh God, you can't see it. Let me move my head in the way here. Let me move this out of here like this. For us, like we didn't have really like the blue part and the green part of this are the 2 parts that we wanted to build out, and the 2 parts that we really decided were like the big thing to work on next. And so when we were looking for tools that would allow us to do that, Kubeflow with its model serving component, which at the time was called KFserve, which is now called KServe, really offered us like literally everything with a color here, right? So you could see that like, I mean, most of it, everything else, a lot of the things we already had, but we could actually get so much of that workflow just by using Kubeflow and KServe, which would give us the ability to manage models, to train models, to compare models, and then to serve models. And so this is sort of what we've been working on. I'm going to move it right here. It's weird to have my face here. I wonder if I could just turn off my face. Let me see. Turn off. Okay, then we'll make it big. You don't get to see my face for this one. So, for us, the this is sort of like our work so far. So if we go here, this is a really complicated slide, admittedly. Oh my God, what's that thing? How do I get that little button out of the way? Get out of there. Get out of there. Get out of there. Get out of there. Okay, cool. Let's move on to slide. So for this, like, this is sort of the state when we first started down this project. It was that there is an existing model serving infrastructure. We call it ORS. It's been very popular. It has been essentially like the first generation of MLOps at the foundation. It is something that was done before MLOps was really a thing, and it sort of made that first big step for us. The issue is that in the time that OR's been up, there's been this huge advance in MLOps and MLOps best practices and that kind of stuff, and it sort of surpassed what ORS does in lots of ways. And so we went back and we were like, okay, cool, what let's take a look at should we keep building ORS, or should we sort of try something else? And we ended up deciding that what we were going to do was actually go back to the drawing board and build out a brand new Kubernetes based infrastructure using Kserve and Kubeflow. And so that's the big gray part is put it here. That's the big gray part here. This is all the infrastructure that we want to build, and this is our sort of existing infrastructure. And so the first thing we did was actually just take that ORS infrastructure and just put a pause on it, right? We'll still deploy models on ORS. We'll still make changes when things get fixed, but we don't want to spend a huge amount of time building new features for ORS because we want to use that time into building the new infrastructure. And then we'll shut down sort of some parts of it that we used for labeling, just to give the team more cycles to focus on the new infrastructure. We also hired a bunch of folks. Going down one slide. So this is sort of where we are now and where we've all been banging our head against for a long time, frankly. Because the foundation doesn't work on cloud infrastructures, because we work on our own infrastructures, if you want to build a new Kubernetes cluster, literally one of the first things you do is you have to buy the boxes that, the servers that you want that server, the cluster to run on. So you need to architect the hardware, and you have discussions about where to put the rack space. Literally, can I plug this box into this rack, or do I need to plug it into this rack? So you have this long set of discussions to make sure that your hardware infrastructure works. And where we are right now is that if you go up, I'm going to go back to slide 15 here. This green part, right, serving the models, hosting the models and running a prediction with the model, is really that. In my head, that was the thing that was the biggest blocker for folks, right? You could train a model locally on your laptop if it's not too big. We also have machines for researchers that can use just a general working compute space for them to use. But that serving and prediction of model hosting was really huge. And so that was the first part of the infrastructure we wanted to build, that green part, right? Which is Kserve, which runs on Kubernetes. The idea is a modern model hosting infrastructure with analytics, everything that we would need to do. And there's so many advantages here to this Kserve approach. The one that I particularly like is the serverless architecture, which means in practical terms, with the old infrastructure with ORS, because it isn't serverless, if you have a server that has 120 gigabytes of RAM or 128 gigabytes of RAM, and you end up hosting a model that's, say, 3 gigabytes, you only have 125 gigabytes of RAM left on the machine, right? Every single model is required to be loaded into RAM, and therefore there's a finite number of models that you can host on the machine. This is super problematic from a variety of perspectives. One, straight from scale, but two, I didn't want us to be in a position to have to be the judge of whether a model was going to be popular or not before we decided to host it, right? So if a community member comes and says, hey, this model is really important to us, but we're only going to use it once a year, I didn't want to to say, hey, we can't host it because we don't want to use our valuable RAM for your model versus, another model that might be used, 40 times a day or something like that. And so with the new infrastructure, which we call Liftwing, which is that K-serve on Kubernetes, it allows us to host, say, it's like, say, 50,000 models. And those models actually spin up when they're used a lot and then spin down when they're not used. So say if you ask for a prediction from an API endpoint that hosts a model, that connects to a model, or put it away, say you ask for a prediction from a model that hasn't been used in like 6 months or something, that first prediction might actually take you a few seconds. And behind the scenes, that K-serve and Kubernetes and Liftwing is like actually spinning up that model, like loading that model into a worker and having it run and like setting everything up for you, like launching that Docker container and all that kind of stuff, having it set up for you so then it can then serve you that prediction. So that first prediction would be slow, and then it would be fast. And that model is would be up for like 3 days or something, and then it would go back down if no one used it. But if people kept on using it, it would stay up. So that means we could actually host way more models and not care so much about how much they're being used or not, because when you're working with like big communities, there's wide variation in how people would want to do this. Some people would want a really important model that runs once a year. Some people want them to run all the time and that kind of stuff, and we don't want to be the arbiters of that. And where we are right now is that Liftwing is up. It is hosting models. We are doing all the sort of test flights. This is bad because I'm just using like aviation analogies here. We're doing a bunch of different tests on it. We're trying to host different models. We're trying to, we're going to start like actually serving predictions and then like try to hammer the server a lot to sort of see how long it takes to do a prediction, all that kind of stuff. You can't actually get the prediction publicly because we haven't connected it to the public API endpoint, which is here, which is called the API Gateway, or api.mediawiki.org. That is this, which is sort of which is the new, going to be sort of the place that you can go to get any API from the Wikimedia Foundation. Right now, it's currently under development. Ours is not connected to that, but it will be as we, pretty soon, as we're still kind of figuring out how exactly to do that. Hey, Nick, how's it going? And so, for us, like, it's super, super exciting because it means that first cluster that we have is actually up and actually running and hosting models. You can't see the prediction. I can go on to our internal system and like actually ping it for a prediction. So it definitely works, but you can't see the prediction, but that'll change in hopefully a week or something. And then we'll be doing like a lot of tests on it and sort of to see if it works before we sort of call it live and in production. And maybe even, we'll go on the live stream and start like playing around. And you can sort of see it and tinker with it and tell us what you think. But the idea behind this architecture approach is that there is a Kubernetes cluster that is dedicated to the serving of models. And the reason that we split up the serving of models and like the hosting of models with like their training is one, because of some nuances of our architecture, but two, the big benefit was that we could make that model serving cluster really, 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 really safe and protected and really, really high uptime, right? Like we could say like, hey, we want that Liftwing part of it that is serving models in production to be up as much as humanly possible. Where the model training part, if it goes down and someone can't train a new model for 3 days, that's okay, right? That's fine. But what we really care about is you have to have the models that are in production have to always be in production. So we've been working through that. The other part, we've been doing on model cards, which I've talked here before, around how do you explain to the community what a model does? How do you invite the community to govern the model? So our goal is that the community would be able to say, hey, here's a model that detects article quality on Swahili Wikipedia. We, members of the Swahili Wikipedia community, don't want that article, don't want that model. We don't believe in that model. We don't think it's good. Don't give it to us. And we could say, and we as the foundation should say, okay, cool. Thanks for letting us know. We'll turn that thing off. How do we build that mechanism in? And the big part for us was the idea behind model cards, which was Mitchell et al. When they were at Google came up with the idea of having a single source of truth for an individual model. Here, I can dump in our version of it. The idea is that there's like a place where folks can come and see what a model is, what's the motivation behind it, who created it, how does it work, who trained it. And so we've been working on a proof of concept of these model cards where we sort of go through this stuff and programmatically generate all this kind of information for each model. So if anybody has any questions about an individual model, they could go here and learn about it. There's a lot of nuance in here of how these things work, but the idea is that, like, you know, we should have something like this for every single model that we have. And the interesting thing about doing this in Wiki is that we can actually add, since every single page has a talk page, here it's called discussion, but every single page has a talk page, you can actually go and like have a discussion about the model right there with the model card. So the public discussion about the model and the model card are like attached at the hip, which is so interesting because it's a place for people to provide feedback, to provide concerns, to provide problems, to find bugs, to like all that kind of stuff, to discuss whether a model's good or not, all that things. There's like a place for that kind of discussion. Let me paste this into the chat again. So that's what we're working on too, but we're pretty far away from this being what I would call live. I mean, this is public, but I wouldn't call it a live product. It's more us experimenting with stuff. And then, you know, the big thing was that like migrating all the existing models that were on the ORS infrastructure and moving them over to Liftwing, such that we wanted to end this period with Liftwing hosting all the models on ORS and ORS continuing to be up and hosting all the models. So like everyone who uses ORS doesn't experience any kind of, you know, change. But for the new infrastructure, we're also having that parity, like the same models on both systems. What we're going to do in the future, so the quarter system starts in June, so this would start in January. Q3 would be like basically like the start of the January 2022. So this would be a few months away where we'll start. Move more models over to ORS, right? Like go one model at a time and start putting more and more models in. Actually release the model cards, right? So like actually decide that, say, hey, we're going to make model cards for as many models as we can, and we're going to put them out publicly, and we're going to tell people we're going out publicly, and we're going to, you know, like support that as a real product rather than like a little proof of concept like it is now. And then like push that Liftwing infrastructure, that model serving infrastructure beyond MVP, like add more things, better analytics, actually do like a scoring cache, right? So which means that like a prediction cache. So like say we make a prediction on every single edit to Wikipedia when that edit is made, and then we store that prediction away. So if anybody wants, say, every prediction that happened in the last week, they don't need to hit the API, you know, 100,000 times. They could just do a database query for 100,000 rows. That kind of stuff is like where we want to go to next. The reason it's sort of spread out from the MVP is like the honest answer is like we're uncertain how much resources we're going to need to host all these different models. So for example, like some of the models require a lot of pre-processing. Specifically, say you want the topic of a particular article, you tell the API, like this is what you do in ORS, you tell the API, like I want the topic of, or the, you know, the article quality of like this article. And you just like paste, you know, like you just paste in the actual article like name. Then that process starts where then it grabs all the text of that article, pre-processes everything that down that could actually be sent to the machine learning model, then sends it to the machine learning model and gets a prediction. And so like that pre-processing step is actually like pretty intense, right? Like there's a lot of IO of like going and grabbing that text and pre-processing of that and that kind of stuff. And we are uncertain in the new infrastructure if that's going to take like a very small amount of time or a lot of time. And so we need to do a lot more tests around, you know, like for example, like ORS does something similar where it pre-caches predictions. But if you don't pre-cache the predictions, it takes a few seconds to get a single prediction out of it. So like you, literally without that pre-cache, ORS is like very, 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 very difficult to use. In the new infrastructure, we have a lot more power behind it and a lot more optimization, but we're still kind of figuring out how much we need. And so once we know more about like, okay, it takes like 4 seconds to make a prediction, that is too much. What are the solutions to that? We could add more boxes. We could optimize the like image size. We could do, we could add pre-caching to that kind of stuff. We just need to figure that part out yet, which we haven't really done. And then beta test, right? Frankly, one of the things that I want is to actually have more folks come in and just try out the system and take a look at it and see what's happening, and tell us if it's good or not. Less on the like actual model side, which is typically where we get feedback, but more on like the infrastructure side of like, this is what it feels like to interact with the system. This is what it feels like to be, like to ask for a model or get a model or host a model or that kind of stuff. And then finally, like to start the very, very, very slow deprecation of ORs by essentially trying to find every single person who uses ORs currently, which is not an easy task, it turns out, and saying, hey, in a year or in 18 months or something, we're going to turn off ORs. I think the timeline was like a year at this date, so 18 months from now, but or whatever, like 15 months from now or something. But to say like, hey, we're gonna turn off ORs. Make sure you update stuff. The new system, we're gonna have the new system up by then and that kind of stuff. So everything will be good. But just to let you know, and the reason to do that year-long deprecation process with like communication and trying to find people is that the ORs infrastructure doesn't require that you have any kind of login to get a prediction, which is really cool. It's also really difficult because that means that a lot of people have hard coded the REST API, actual URL into their app. And there's no login. There's no reason that we should know that they're using it or not. And it's hard for us to understand who's using it. So like, it's hard for us to ask them like, hey, just to let you know, we're going to deprecate this thing in a year. So there's some strategies that we've come up with that I need to think more about whether, like, how would you end up making that happen? Like, how would you end up like reaching those people and letting them know that ORS is going to, ORS is going to be replaced by something else. So you're going to need to change your API endpoint. Next, why is the date? See, this is where I like notice things have changed in here. What's this one? Oh, it's just the same thing. Yeah. So like, I think I need to change this date. This date doesn't seem right to me. What we do after that is move more models into ORs, and then like start to focus on the community process. So this is the part that's actually really interesting from my perspective, that we believe that the models hosted at the foundation are for the community and for readers, and therefore there like needs to be a mechanism for those communities to actually govern those models. Some of that is actually deploying models that the community asks us to deploy, right? Someone makes a model and they want us to host it. How do we take that model on and say, hey, if there's ethical implications of the model that you have made, we will take on responsibility for managing that and testing for that and looking at that. Like, how does that process work? Because we believe that we have an ethical responsibility for all the models that we as the foundation host. Well, if we didn't make the model, what are the risks that we would like have for like someone, especially if someone's anonymous and they just sort of submitted some model and we don't know anything about the model and that kind of stuff. Like, how do we go through the process of evaluating that model and deciding if it's something that we should host, if it's something that's valuable, if it's something that the community wants and that kind of stuff. And then two, like, how does the community give feedback? How does the community say this model's bad, we need to fix this model never worked, which I think is the case of one model. These models are good, this model's too old, we need new training, like all that kind of stuff. How does the community have and like govern the models that we're hosting? And we have ideas of how we might do that. Currently, that is done in a very, very, very ad hoc way. All of this is really done in a very, very ad hoc way. And I would like to get to the point that we actually have a more formal public process for reasons of equity, right? Like, you shouldn't need to you shouldn't be in the part of the inside circle that you understand how you can deploy a model with us in order to deploy a model with us. You should just be able to read the docs and say, this is what you need to do to deploy a model with us. Like, there has to be communicate. You have to have a talk period where like members of the community of the that would be impacted by the model would come and tell you if they want the model or not, and all this kind of stuff. Follow that procedure, and you're good to go, and we'll deploy the model. We just need to work out exactly what that would mean, and I think that's still definitely like still us trying to figure that out. That we'll end up doing in the future. The next one. And this is the one that scares me so much. So Trainwing, so Liftwing is the model serving infrastructure. That's what's being used to actually host a model and host a ready trained model and serve it out to people. We also want an infrastructure for training models. And this is a lot more complicated than the model serving one, and something that we're going to need to think a lot about. For a variety of reasons. So, for example, it needs to connect to our, whatever you want to call it, data lake, our data warehouse. It needs to have access to our data so we can have those features to train on. We would want what is called an offline feature store, not offline as in like not on the internet, but offline as in like it is not designed to serve data really quickly. It's designed to have a lot of data, right? So like that would mean that there's an intermediary database between the data lake and our training infrastructure where we pre-process all, a bunch of features that we use into a place where the modelers, the actual like researchers or machine learning engineers can take a feature off the shelf and use it in their model. That's a big task. Like there's lots of the complicated parts behind the scenes of how to connect those two infrastructures together. The one that we're actually looking at, the open source library that we're currently looking at is called Feast. Although I have not done like a full review of Feast yet, but that's the infrastructure. This is the one we're thinking about as like the library that we would use to set this up. So we need to do more work and to like try to figure out how we can actually have like a feature store and what we need behind it. That one's scary. The training cluster itself is also scary because we need to have GPUs, which the foundation has GPUs that it uses for training, but it's never been super easy. Like we're not really experts in setting the infrastructure up with the right GPUs and stuff like that. And there's lots of nuance between like how to make the hardware work. Do we use like an NVIDIA GPU with an open source version of CUDA, which is like the thing that connects the GPU to the actual system? Do we do like AMD GPUs, which have an open source version of that? Because we basically have to use open source software. And so like how do we make that thing work? Plus the system would be used by a lot of people just around the foundation, like researchers and interns and other engineers and all that kind of stuff, which is just like just new. It'll just be different. So that one super scares me. And I'll be tackling that I guess a year from now. And then, like the big one is like shutting down ORs. Like finally, okay, we've given everyone a year. We've reached out to every single person we could possibly find. All the models that have been hosted on ORs have been moved over to Liftwing. So there's an alternative for any model that you want. This is like the new place to go. Like we could finally shut down the servers, which is also timed with two important parts. One, the ORS infrastructure uses Debian Stretch, which is a version of the Debian operating system. And we looked at what it would mean to update that Stretch one to the newest version, or the version that we use the most. And we kind of think it might break the system, so we're really terrified of actually doing that without like doing a huge amount of work. But around this time, Stretch would actually end its life as a supported operating system. And so like we're basically at like a hard line that we need to actually like, basically shut down the system. And then also all the servers that were originally bought to run ORs, they would be at the end of their warranty, which means it can be harder to find parts. It means that like stuff will start to break on the infrastructure, and you'll need to cannibalize some of the servers to like put parts into other parts of the service to make it run. So another reason that like we should, it's kind of time to like shut down the org's infrastructure. And then the last one is finally, right, you have a model serving infrastructure that you've built, you have an API endpoint that people can reach, you have a training cluster people can use, you have a feature store that you can store information. We really want to eventually get to the point where different communities on Wikipedia, right, English Wikipedia or French Wikipedia or Swahili Wikipedia or anything like that, could are able to send us training data automatically, which would mean that we could actually finally get to what we talked to at the very beginning, which is that circle of training, right? So new training data comes in to, like, we're calling it pilot flag, but like new training data gets gathered on, say, what people think are good quality articles or not. That goes to like our sort of feature store. We use that to train a new model. Then we host that model in production. We see, and then the next day we train like a new model with the latest data, right? And so like there's this like loop that's just constantly going over and over again. That's that endpoint that we want to reach. That's that sort of best practice of, to go back to an old slide, like that sort of circular best practice. We would finally be able to reach that at that point where we're actually gathering that training data automatically coming in. But yeah, I mean, that is years of work coming up in order to accomplish that. And a lot of it is very complicated because it involves lots of different people who don't work at the foundation. I think that's sort of the best and hardest part of working here, is that there's a lot of people who spend a huge amount of time that we support, right? They spend a huge amount of time. They spend like 20 years working on Wikipedia. We're here to support them. But they, they don't have, they have their own goals around Wikipedia because the foundation doesn't own Wikipedia, right? We support Wikipedia. We don't own it. And so people who work on Wikipedia can go in a different direction, and we're sort of there to like help them wherever direction they end up going, which can just be, add a lot of complexity to stuff. So there's that. I don't know if people had questions. If you don't, that's totally reasonable. And I can talk forever about, I don't even know how much time we have left. We have 20 minutes left. I could talk about model cards. Let me turn on my face here somehow. Face cam. That wasn't the right button. That did not work at all. God knows what happened. Oh, look, there's my face. Wait. We're going to drag my face over. We're going to size it, make it look good. Nice. That's what we're kind of thinking with that. For the model cards, if someone has questions, for the model cards, we're kind of at like this impasse that we need to work out where, okay, so let me do this. I will show you an example. Google model card. Okay. Model cards were initially conceived by some researchers who are smarter than me, who work at Google. Hey, that wasn't the right one. God knows what happened there. Let's go like that. It came up at Google. This is the Google site that they sort of are using to demo model cards. They have two examples of model cards. We'll do the face detection ones. This is what Google originally envisioned as the concept of a model card. It is beautiful. It is interactive. It is designed for public consumption, right? So like, it's not designed for an engineer who is trying to fix the face detection model if it's broken or something. It's actually for someone who, just wants to know that model exists and how it works and how it, should or shouldn't be used. That makes sense. The issue is that there is a separation here between the model card, which is public facing, right? This is designed for the general public, and say the internal documentation. God, this mic is like really low. The internal documentation around a model. So for example, my team, if the face detection algorithm is broken, we don't have face detection at the foundation, but if we did, if the face detection was broken, what does the engineer need to do to fix it? So that would be like, our deployment pipeline. We would have like a link to that. We would have a link to like the run book that, basically run book being like the lines of code the engineer would need to run to do common tasks. all this kind of like internal documentation around it. And in my head, when I first thought about model cards, I was like, well, one of the main users of the model card should be the team, because that would mean that there is a single source of truth for a model that is used both internally and externally. So this would be that if a new engineer joined the team, I could say, hey, the face detection algorithm is broken, and they could go to the face detection model card and have, see everything that they would need to do to fix that model. One, they could understand what that model does, right? Because it's in the description of it. They could also see examples of how the model's used, but then they also have information about like how to fix it, right? Like here's a link to the run book with like the things to restart it. Here's the deployment pipeline Helm chart, and here's that kind of stuff. Here's a link to the code, right? And here's the link to the data, and like all that kind of stuff that they would need to fix it. And I realize now that just talking to Auntie, who's on my team, I realize now that is not how people have been envisioning model cards. At least, like, there's not like a lot of examples of model cards out there, but at least the examples that I've seen don't seem to do that. They are very, very, very only focused on allowing the person to understand the model. So, for example, there's nothing in here that an engineer would need to fix the model, right? Like, there's no like link to the code. There's no link to the deployment chart. Obviously, because it's like, it's Google, you can imagine they like, you're not going to help Google deploy anything. So like, you don't need to know that information. However, the foundation is different. We are as transparent as possible, right? Like, we want you to see everything that we're doing because you are the people who end up funding us. So would it be valuable to sort of turn this on its head a little bit and combine internal users and the public into one model card? So that would mean that, like, say something like this is the model card. Say something like this would also have everything that an engineer would need to do to actually fix that model. And some of that wouldn't be useful to you as the general public, but it would mean that the general public and editors and volunteers and say technical volunteers who are helping with something and my internal team would all be using the same single source of truth for that particular model. Because the worry that I have is that if there is a public model card which is designed to show the public what's happening with the model, and there is internal documentation that's being used by the engineers that the public doesn't really see, there is two sources of truth. There's the model card and there's the internal documentation. And the internal documentation will always be the one that the engineers make sure is absolutely right, because that's in their self-interest to like make it as accurate as possible because they're the ones who are working on the system. And so then a change might not come down to the model card, right? The model card could be out of date because it's been changed. Whatever the fact is has been changed on the internal documentation, but not on the model card because of some slip up or something like that. And so you could get around that by just having one model card. So Hal, who is a privacy engineer at the foundation, ended up building this, which I can link to right here. This is a version of the model card that we have for the model called English Wiki. So it predicts whether or not a edit was made on English Wikipedia was made in good faith. Right, so like it wasn't a bad faith edit. It was like a good faith attempt to make the article. It could be a bad edit, but like it was made in a good faith in an attempt to like make the page better. And so, it has all these parts to it. This is where we sort of describe that, like, hey, this is everything on this looks like a Wikipedia page, but it's actually all created by a bot. So you can't actually edit it, or I mean, you could edit it, but it's going to be wiped in a day. This is a tier system of us saying, hey, like, this is a card that we know, like this is a model that we know a lot about, so we can give you lots of information. The idea is that like there's some models that we wouldn't know that much about, and so we might not be able to provide that like top tier information about it. To give an example, the translation team at the foundation has been experimenting with using Google Translate to provide like almost like a code completion for translation. So the idea is that like if there was a piece of text that we wanted a volunteer to translate, there could be like using the Google Language API to actually translate that just as like a draft of like, hey, this might be the thing that you want, human translator, but check it yourself, write it yourself, and make sure there's a human in the loop of that decision. But of course, we don't know everything about the human translate, the Google's translation model, and so like we might not be able to make a model card of that of like top tier level, right? We'd have to say, hey, we only know certain things about this. We use it, so we're telling you that we're using that model, but we don't know everything about it. And so like this, it wouldn't be tier 1, it would be tier 4 or whatever. I don't know exactly how the tiers work. You can see all this other stuff, like who created it and this kind of stuff. And the thing is that like this comes from that Mitchell et al. Paper of like us trying to figure out like what's the motivation behind it, what should it be used for, what shouldn't it be used for, and that kind of stuff. But I still think that this is the stuff that an engineer would want to have when they were trying to fix the model. An engineer being like a volunteer engineer who's like helping us out, or like one of the members of our staff, that you would want to know that a model shouldn't be used for something, right? Like in your work as an engineer, you might like say fixing the model, you might care that shouldn't be used. And so like there's information on the model card that would be useful to folks internally. And so why not just put everything onto it? But then, of course, you like wonder if it's actually a model card. It's actually we're just writing documentation and calling it a model card. Probably. I don't know yet. I kind of like how this is going. This part, how was trying to figure out how to like. So this comes from like a text document that he like pasted in, because it wasn't programmatically extracted from the stuff it was like manually copied and pasted by the creator of the model. So there's that. I mean, does someone, but then like also like something like this, right? What's the architecture of actually the prediction? This is just documentation. Like this isn't the model card, right? Yeah, max depth, log 2, like, I mean, that's the issue with this. Like, where's that line between the model card, like where's that line for the foundation between we want to tell you as much as we can, or like we want to tell you a lot about what's happening, but we can't just flood you with information, right? Like you're using the Friedman mean square error. Should you know that? Do you care of that kind of stuff? What's the minimum sample for like a leaf, right? So like how many samples are allowed to be in a leaf? Like, is this actually, should this be in the model card? Or should we say there is stuff that is in documentation, like something like this, and then there is stuff that is in the model card, this is me scrolling up here, which is stuff like this. And I don't know, to be honest. I lean towards putting everything in one place, but I don't know if that sort of undermines the concept of a model card by basically calling documentation the model card, right? Yeah. I don't know. We're going to talk to more folks about it in the coming weeks to try to figure it out. But it seems to me like there's a line between documentation and model cards that other organizations have made, where the model card is just a small public facing part of the documentation, probably the only public facing part of the documentation, of a much larger documentation. And if that actually is within the fit for the values of the foundation, I don't know. I mean, who cares? Who would care about this stuff? Who would care outside of the engineer? Well, but see, I mean, if you were going to take the model and run it yourself locally, would you care about this stuff? I mean, you would in some sense, but you could probably just get it yourself. I don't know. What's the schema, right? This is documentation, right? Like, so what this is asking for is like, this is the actual, this is what gets returned from the model. So like you hit the model endpoint and it comes back with like this. This is like straight documentation. So this shouldn't be in the model card, right? Yeah. So there is some kind of line, I guess. I don't know. Napster and Blue says, yeah, if you look at the face detection model card, let me bring that one up. Model card, face detection. There's a link to the API docs a few lines below the center image, which is basically what the model card information section. Where is it? A few lines below the center image. Center image? Oh, the public API documentation. Yeah, I mean, there has to be some split, right? Because you can't just put everything into the model card. And like you could maybe that's the strategy, is not to put everything into the model card. I'm going to go back to the model card. Not to put everything into the model card, but to make the model card the like central, like if you imagine like a star schema, if you've done databases, right? You have some central table that connects to all the other tables that you might need. You could almost imagine like this is like the model card could be the star of your documentation schema, so that you could point either an external user or an internal user to the model card, but then from there they can sort of choose their own adventure down through the different docs or something like that. Maybe that, but like this to me is just straight. This is straight documentation, right? And I'm not inclined to reinvent documentation. If someone's going to use this model, I'd rather have just straight normal documentation that looks really familiar to the engineer, either an internal engineer or volunteer, that just like looks the same. Napster and Blue has like a really good point that like maybe, like this is totally different. Maybe this part is, yeah, probably. This does mean I'm wrong, and Andy was right. I don't know. Anyway, we have 5 minutes left. I'm happy to take any kind of questions, but that also, the point of this whole activity is just to see us kind of work through these things. And so I don't know how it'll turn out. We might use it that like model cards are sort of a part of the documentation, but like a special part designed for public consumption, or frankly, we might just use it as like the central cockpit of the model, of which you can use to work anywhere. I am uncertain how that will pan out. But yeah, any questions? Otherwise, I am going to get a much needed lunch. 12:30, yeah, definitely getting lunch. I'm going to give it a few more seconds. Maybe I'll look at Feast next time we do this. Cool. All right. Thank you, everyone, for coming. We will do this again in 2 weeks. If you have any feedback, on it, go to. I'm gonna go right here. I'm gonna dump this in here. I'm gonna put this in here. Just dump the feedback in here somewhere. You can just start a new topic, and write in some feedback. I just want to hear how people are using for this. This is not something that we've, the foundation has never really live streamed something like this before. They've live streamed things where you're like not just like one person on Twitch. They've live streamed like set presentations, not like just random Chris babbling about stuff, and live coding or something like that. So I'll be interested to hear what people say. Cool. Awesome. All right, everyone. Have a good day.